Hello everyone, I am Roshan Bhatta and this is my second tutorial on YouTube about some basics input output in AVR microcontroller. So in the last part we discussed a little bit about the output in AVR microcontrollers. So in this tutorial we are going to learn a little bit about the basic inputs, how you take the input into the microcontroller. So as like our previous tutorial, we'll be using Atmega 32 for this. So let's start. And if this is your first time watching my video on YouTube, then better watch part 1 and come to part 2 so that it will be easy for you to catch up what I'm going to say. So let's directly start with the programming. This is AVR Studio. So we are using AVR GCC compiler. Let's say this as input, then going to create the initial file and a folder also. So I'm going to choose my microcontroller. Okay, setup for the project is complete. So let's start with the programming directly. Today I'm not going that much detail because all the stuffs related to programming ports and all those stuffs I've already explained to you guys in previous tutorial. So if you have not watched it, you can watch it over there. Okay, we are ready for the main part. Okay, let's start. Now let's suppose that we are going to use port A for inputs and outputs. Okay, not outputs, we are going to do inputs. So we are using port A for input, but there should be something to check the output, isn't it? So we'll be using port B as output and port A as input. It's not necessary that you have to use port A or port B. You can use any port you want and any pin in the in any ports. Okay, so for this case I'm going to use port A as input and port B as output. So as I have already told in the previous tutorial, for input you are going to assign 0 to the appropriate bit that you are going to use of that register, DDR-A or DDR-B, DDR-C, or that might be DDR-D case of Mega 32. Okay, so cross 0 0. This means that I'm setting all the bits of port A to be low, port A data direction register to be low. This means that this means the DDR-A just selects the mode you are going to use, and there are two modes, output and input. So if you assign bit 0 to any pin, then that means you are selecting the mode to be input. If you assign 1, then you are selecting it to be output. Like let's say 0 cross 0F. This means 0B in binary, 4 zeros and 4 ones. This means for the most the lower nibble are output and higher nibble are input. Let's see here in the figure. That means according to that line, what it says is pin number 40, 39, 38 and 37, we are selecting it to be output pin, and pin number 36, 35, 34 and 33 to be input. But in this case I'm not doing this way, because I told you I'm going to use port B as output and port A as input. Okay, now I selected the mode for port A to be input. All the pins of port A are now input, and all the pins of port B are now output. Now in case of input, what you have to do is either you have to add some external pull-up registers, or you can also enable internal pull-up registers. And what is why do you need that pull-up register? Actually, whenever you select the pin of a microcontroller to be input pin, then you really don't know whether it's in which state it is in. So to be sure that you want it to be always high when you are not clicking, or let's say when you are not pressing any button, or you want it to be always low, then you either can add some external pull-up resistor or pull-down resistors if you want that too, or you can just enable the pull-up resistor that is already built in the microcontroller. So for that, what you need to do is port A is equal to 0 cross FF. Now suppose what this line does is, let me write some extra line over here. Let's see. Now this port A and port B, I have set all the bits of the port A and port B to be high. But let's see the mode first. Port B is in the mode of output, so this means that all the pins of port B gives me 5 volt. If I check right, if I just flash this into the microcontroller and see its output, then I can see that port B has all 5 volt coming out from all the pins. But what about port A? It's in input mode, so this means, what it means is, whenever it's in when some port is, or some pin of the port is in input state, and you write you set the bits in that port, or that appropriate bit, then what happens is you are just enabling the pull-up resistor. Okay, now if I just write F0, what this actually means, 0P first higher nibble 4 bytes, I have just set the pin, and remaining a lower nibble I have reset the pin. This means that I have just enabled the pull-up register for upper 4 pins, that is pin number 40, pin number 39, 38 and 37. These pins have pull-up enabled, and 36, 35, 34 and 33. These pins don't have pull-up enabled according to this line. Okay, so but for now I am going to enable all the pull-ups, and I'm not going to write anything in the port B. This means by default it's 0. So now what I am going to do is, I'm going to check whether the pin is pressed or not. So how do I check that? Okay, let's say that let's suppose that I'm going to add a switch in the pin PA0. Okay, and then I'll be giving the output to PB0. This means whenever I press the button in button that is being connected with this PA0 pin, then a lead at PA0 should PB0 should glow, and whenever I release the button, then the lead should should not glow. Okay, so let's slide the program for that. Now how do you check the state of the pin, whether it's been pressed or not? So first of all, let me make a circuit also, so that it will be clear for you. Let me make a 32. By the way, this is Proteus. You can, if you don't have idea about this, then you can just what's happening with this program. I don't know, whenever I open this library for the first time, it's going to be hung for some time. What is this? What's the problem with this one? Okay, I'm going to add now. You see, for the second time it works fine, but for the first time I don't know what's the problem. Maybe some problem with my computer. Okay, I'm adding a lid, and then what else we need? Yeah, we need a switch. Do we have a switch over here? Okay, let me add a button. If there are, okay, there's a button. Okay, now actually I'm using my laptop right now, and so it's a little bit hard for me to zoom the area. How do I zoom this area? I don't know. Okay, zoom to area. It's over here. If I had a mouse, then it would be very easy. Right now I don't have a mouse with me. So okay, what we said is we are going to use this PA0 for placing the switch over here. Okay, since we are using pull-up resistor, we have enabled the pull-up resistor, so I'm going to connect this to the ground, and then let me add this layer to PV0 pin, and this one let me connect it to ground. Okay, so right now you cannot play because you have not loaded the X file over here. See, you get an error over here. So what I want to do is, whenever I press this button that is connected with port A pin number 0, then I want this LED to glow. That means I have to give 5 volt to PV0 whenever I press this button. Now whenever I release the button, what I want to do is I want to give 0 volt to this, so that this LED is not going to glow. Okay, so let's slide the program for that. Now, by the way, to denote a pin 0 of port A, you can write PA0. For pin let's say 5 of port A, you can write PA5. Okay, otherwise you can just write 0 for PA0 or 5 for PA5. Okay, you can use it this way. Now, how do you know that this pin over here is pressed or not? So what happened is, we have just enabled the pull-up resistor over here, isn't it? So let me make it a little bit clear over here. Resistor. Okay, it's a resistor, and let me put the resistor over here. Let me, if I rotate this. Okay, now let me put this over here, and let me put one power source over here. Okay, so if you are thinking what is pull-up resistor, then the resistor just now I have connected, this one is a pull-up resistor. Okay, this part, if you in the programming, see, we have set all the bit of port A. This means that this resistor is already internally connected with this microcontroller. You don't have to put some extra pull-up resistors over here. I'm just making this circuit so that to make you clear about what actually is this pull-up resistor. Okay, for now, suppose that this is the internal pull-up resistor. After explaining you a little bit about this, I'm going to just erase this one. But for now, think that this pull-up resistor is inside this microcontroller. Okay, whenever, what's the problem? Okay, whenever you are, I think DDR A is equal to 0 cross 0 0, this means that you are in this state. Okay, this pull-up resistor is not connected to any pin of your microcontroller. Now whenever you write port A is equal to 0 cross FF, then all the pins of port A are automatically connected to the internal pull-up resistors, like this one. Okay, now whenever I am not pressing this button, then what is going to happen? Let's see over here. Since this is an open circuit, so this becomes the complete part. This means you are in the logic high state right now. Now whenever you press this button, there is a 10k resistor, but there are no any resistor, so this way will be easy to complete this path. So current is going to flow from this switch to the ground. That means whenever you press this button, then you will be getting 0 volt at port A pin 0, but when you are not pressing this button, you are going to get 5 volt. Okay, so how we are going now, let us erase this one, because as this is already internally connected with the microcontroller and we have enabled that. So I'm going to write pin A. Now in this pin A register, you have all the records of the input bits. Okay, now I'm going to check 1 shift PA0. Okay, this directly means, indirectly means, not indirectly, pin A and 1. It is this commented line is same as this one. Okay, but this looks a little bit good. Whenever you suppose, it's okay if you write even this one that I have commented over here, but whenever you write this one and you give somebody to just read the code or edit your code, then this one becomes a little bit easy. Okay, this becomes a little bit easy, because right now I'm using port A pin number 0. So okay, you can, if you even write this, then I can understand that you are looking at pin 0 of port A. Now suppose you are writing 16, then yes, I know that this one is you are trying to look for pin number 4 of port A, but if you would have written PA4, then it would be a little bit systematic, it would be a little bit easier to check that okay, you are looking at pin 4 of port A, okay, then to look at this. But it's up to you. If you are just writing the code and you don't want to follow you can do whatever you want, okay. So right now I'm going to use PA0. Now what this line means is I'm ending all the bits of PA with PA0. This means I'm ending pin A with 0B000000001. okay. Now this means that whenever this pin is at 5 volt, then I'll get the result true over here, isn't it? I mean I'm ending with the first bit, isn't it? Now whenever the value of pin A 0th bit is 1, that means whenever there is 5 volt as in this pin, then I'll get a value of true. But you will always be getting 5 volt over here. When you press this button, then you are not going to get 5 volt, because current is going to flow to the ground from this circuit and you will be getting 0 volt. That means I have to just invert this part, okay. I just invert it. Now what happens is whenever you press the button, then this condition becomes true, okay. Whenever this thing is going to happen, then I'm going to set all the bits of port B to be high. This means give 5 volt to all the pins of port B, okay. Now let's write for the else part too. Else port B 0 cross 0 0, else give 0 volt to all the pins of port B, okay. So let's compile. I'm pressing F7 for compiling this part. You can go to the build and here's a build F7, okay. I got one warning, maybe that I have not defined FCPU, okay. You can define that. By default it's going to take 1 megahertz at FCPU, since we are not using any delay function or any timer function, so I'm not considering anything about this warning, okay. Okay, now let's go and load the hex into this microcontroller. I'm going to locate the file. I don't know where this file actually is. I've seen AVR story input. Let's see. Okay, let's go to where are the users. Okay, here's the X file, and we will press OK and let's run this. Okay, you can see I have not pressed this button and the lid is not glowing. Now let me press this button. You can see that the lid glows. Now I am going to release the button and the lid doesn't glow. Okay, let's see once again. When I press the button, the lid glows, and when I open the button, when I just open circuit it, then the lid doesn't glow. Now notice that not only the pin in this and the pin 0 of port B is high. You can see you can see the small red dot over there. Whenever I open circuit the button, you see that all of them are turning into blue. That means that it's all of the pins of port B are now in 0 volt. Whenever I click this, all the pins of port B are at 5 volt. That means all the pins are giving 5 volt, and if you connect a lead to all the port, any of the pins of this port, then you can get 5 volt from all the from that pin, okay, from all the ports. Now but it's not same with port A. You can't connect this switch to PA0 for the same program. You have to edit, because let's see in the programming part, I have checked only the PA0, okay. I have not checked PA1, PA2, PA3. So that means you have to, according to this program, you have to connect the switch at pin A. Sorry, pin A, port pin 0. Okay, port A, pin 0. Then only you can see the output. Now, okay, this, what else is left? Okay, this is all about the inputs. In the next tutorial, maybe we will be learning little bit some application of inputs and output. Maybe we will be learning something about using the keypad, matrix keypad, and all those stuffs. Okay, thank you very much for watching the tutorial.